Can you hear me? I think only 15 students are live now. And then out of 62 students enrolled altogether. Okay, so 14 of you are live, 16 now. So we can wait for 2-3 minutes so that some of your friends, okay, can come live. Since I have muted all of you, you won't be, when you speak, I will not be able to hear, because if I unmute, then you'll be disturbing the classes, okay? If you're able to hear me, you can please comment on the chat here and say that you can hear me. I think the chat option is open for all the students. Okay, so you can hear me. Okay, that's good. Yes. So 26 students are coming live now. Some of your friends, they are only sending the request now. So it is going to disturb the class. Yesterday, I think they were sleeping. Yeah. Okay, then we shall start. Okay, there is no need of any kind of introductions now. See, I have uploaded several videos on some of the chapters during your first terminal examination. I don't know how far you are learning. I am sending the link through WhatsApp, and I'm uploading all those videos, okay, in YouTube. So I think you need to get the help of those videos, okay, in order to like learn more in detail about the chapters that we have completed. Since we have very limited time for our second terminal, so we cannot, we don't have enough time to revise on all those things that I have completed. So from the chapters, from your first term chapters, you please, you need to watch those videos that I have uploaded on the YouTube, okay? And I have sent the link of all those videos in your WhatsApp group, Class 10 WhatsApp group. And currently I am working on with quadratic equations chapter 4. Chapter 4 is included in your second term syllabus. So I'm working on with the videos on chapter 4. I'm almost about to complete. Okay. This morning I have also sent you 2 videos on exercise 4.3 chapter 4. So that you have to learn, okay, through the YouTube that I have uploaded, and I have sent you the link even this morning. And here in this class, I'm going to start up a new chapter, chapter 9, applications of trigonometry. In your first term, you studied about trigonometry in chapter 8. So on continuation, we are going to learn chapter 9, applications of trigonometry, okay, which is included in your second term syllabus. All right, then we shall start, okay? Applications of trigonometry. What is trigonometry? That you have already learned, okay, in chapter 8. Chapter 8 was introduction about trigonometry. So you have already learned what is trigonometry. So I'm not going to have any introduction on what is trigonometry. Strictly, I'm going to focus on the applications of trigonometry. This chapter is also known as height and distance. Height and distance. Means in this chapter, using trigonometry, we are going to find out the height and we are going to find out the distances, okay, of several things. All right. So we shall start. I think before we start, I think every one of you is along with your textbooks, right? Because since the board is small, and I don't want to waste any time writing down the questions, so for the questions you can refer it from your textbook, and I'm only going to uh, give the solutions. Okay, for the questions you can refer to your textbook, and we are going to work out only with the solutions because we have limited time. Our class will be just 1 hour. Okay, so we shall start now. Applications of trigonometry. There are like few concepts that you need to learn here. So we need to be clear about what is angle of elevation, angle of elevation, and angle of depression, angle of depression. So these are two things that you need to learn before we start solving the questions of this chapter. Okay. This chapter contains only one exercise, and in the final exam, there will be one question carrying 5 marks from this chapter. Okay, so this is a very important chapter for your examination. It carries 5 marks, there will be only one question for 5 marks. So angle of elevation, let's try to understand first what is angle of elevation. Now, suppose I draw a person here. What does a person do? He observes things. So I'm going to refer this person as the observer. This particular person is your observer. Okay, because what people do is we observe things, right? If there are some objects nearby us, then we always look at it. So we are observers. So consider a boy, okay, standing somewhere, and since he's going to look up or look down at some things, he's going to observe things, so he will be considered as an observer. Now, from the eye of the observer, okay, from the eye of the observer, you just draw an imaginary line, an imaginary straight line, an imaginary straight line, which will be parallel to the ground. Okay, suppose if this is the ground, if this is the ground, then if I ask you, just say that this is a ground, this is your ground level, this is the ground level. If I ask you to draw a line parallel to this ground, then this is how you have to draw, right? So this is a line parallel to your ground level. And if I ask you to draw a line perpendicular to the ground, and if this is the ground level, if you draw a line perpendicular to the ground, then it should form 90 degrees. All right? Yes. So this is the observer. From the eye of the observer, you always draw a straight line, an imaginary straight line, which will be parallel to the surface of the ground. This line will be called as the horizontal line. Horizontal line. Are you clear? Okay, are you clear? From the eye of the observer, you always draw a straight line, an imaginary line, okay? An imaginary line, a straight line, which will be parallel to the surface of the ground. This line would be called as horizontal line. All right? Now, Suppose this observer, he may look up at an object or he may look down at an object. Let us consider that he is looking up at an object. There is an object at this position A. Okay. Suppose there is an object at that position A. Now let us say that this observer is looking up at an object which is placed at the point A. Then you draw another imaginary line connecting the eye of the observer and the object. Okay, you draw another imaginary line connecting the eye of the observer and the object. So this particular line will be known as the line of sight. Line of sight. S-I-G-H-T, line of sight. Now, so this is your horizontal line. This is the line of sight. Now there is an angle formed in between these two lines, right? There is an angle formed in between the horizontal line and the line of sight. This angle may be equal to 30 degree, 45 degree, 60 degree. Okay, it can have any values. So the angle formed between horizontal line and the line of sight. Let me represent this angle by theta. This symbol is known as your theta, which we use in math to denote the angles, right? Yes. So the angle between the horizontal line and the line of sight, it is denoted by theta here. So this angle formed is known as your angle of elevation. All right. So the angle formed between the horizontal line and the line of sight when the observer is looking up is known as the angle of elevation. Are you clear? Okay. The angle formed between the horizontal line and the line of sight, okay, when the observer is looking up at an object is known as the angle of elevation. I'm not going to write down the definition, okay, so you can just note it down by yourself, all right, okay, yes. The next one is angle of depression. Angle of depression. In the first case in elevation, the observer was looking up at an object. This time he is going to look down at an object. Okay. So this is the observer. Okay. This is the observer. See, the same thing. From the eye of the observer, you always draw a straight line, an imaginary straight line, which will be parallel to the surface of the ground. That line, we will call it as horizontal line. And also we have drawn a horizontal line, right? How did we draw horizontal line? From the eye of the observer, you always draw a straight line, an imaginary straight line, which will be parallel to the surface of the ground. That is known as your horizontal line. Now let's say that this time, the observer is looking down at an object. The object is placed somewhere on the ground. Okay? So the observer this time, he looks down at an object. The object is placed at B. So the observer is looking down at an object at B. So you draw another imaginary line connecting the observer eye and the object. Whenever you draw a line connecting the observer eye and the object, then that line will be known as the line of sight. S-I-G-H-T, sight. This time also, there is an angle formed in between the horizontal line and the line of sight. This angle may be equal to 30 degrees. It may be equal to 45. It may be equal to 60. Is it okay? Let me denote this particular angle by theta. All right. So the angle formed between the horizontal line and the line of sight when the observer is looking down at an object. This time he's looking down, right? The angle formed when he is looking down. So the angle formed between the horizontal line and the line of sight when the observer is looking down at an object is known as the angle of depression. You can note these two down. All right? Yes. Is it visible? Can you see every letter, every symbol there, right? You can please comment on the chat, okay? Because I have muted all of you. So even if you speak, I will not be able to hear anything. So you can please comment on the chat, okay? Yes, everyone is responding, yes. Okay, all right. Okay, thank you for your response, okay? Good students. So, based on this concept, we are going to start solving questions of this chapter 9, okay? That is exercise 9.1. So if you are done noting it down, I'm going to just remove it and then we shall start solving the exercise problems. All right then. So students, you can please look at it at your textbook, okay? Exercise 9.1, we shall be starting with the first question. I'm going to take the help of the textbook, okay? Your class school textbook. So let us look at the first question. Okay, when I read the question, you can also refer to your textbook, okay? So we have altogether now 51 students. Okay, that's out of 250 students, we have only 53 students now. 53 students now. Some of them are sending requests only now. I cannot accept because I'm going live. Okay. So the first question, let me read the question and then we will together work out with the solution. Okay. I'm going to solve it. You're going to copy it down. So we are working together here. As circus artist is climbing a 20-meter long rope. Oh. So there is an artist, okay, a circus artist who is climbing a rope. The length of the rope is 20 meters, which is tightly stretched and tied from the top of a vertical pole to the ground. Oh. The rope in which the artist is climbing is tightly stretched from the top of the vertical pole means a straight post, okay, to the ground. So the rope has been tied from the top of the vertical post to the ground. Pole means it's a post. Find the length of the pole if the angle made by the rope with the ground is 30 degrees. I think there is a figure given in your textbook. We can refer to the figure. So let's say that this is your pole. This is the vertical pole. Let me denote it by AB according to the textbook. All right. So this AB is your vertical pole. A pole, a building, a tower, they always stand perpendicular to the ground. All right. So if AB is the pole, and if this is the ground, if BC is the ground, then the post will always stand perpendicular to the ground, means making an angle 90 degrees. So the rope is tightly stretched from the top of the vertical pole to a point on the ground. Okay, to a point on the ground. So see, this is the rope. The rope is tightly stretched. Okay, it's very tightly stretched from the top of the vertical pole to a point on the ground. And then the length of the rope, here AC is the length of the rope, which is given to be 20 meters. Okay? And see, this is the rope, AC is the rope, BC is the ground. Question says, the rope makes an angle of 30 degrees with the ground. So this angle is 30 degrees. This angle is 30 degrees. Our aim is to find out the height of the pole, length of the pole. Here AB represents the length of the pole. This is what we have to determine. Correct? Okay, all right. So we want to determine the height of the pole. So we have denoted by AB. So let AB represent or be the height of the pole. Height of the. This is our objective. This is our objective. This is what we have to determine. Now this is a right triangle. In chapter 8, we have studied that altogether there are 6 trigonometric ratios, right? Okay. Sine theta, cos theta, tan theta, cot theta, cosec theta, and sec theta. Then sine theta is given by, suppose say that this angle is theta. Instead of 30 degree, let's say that it is theta. Okay. Then sine theta will be given by what? Side opposite to angle theta, which is AB, right? AB stands opposite to your angle theta. So side opposite to your angle theta upon the hypotenuse. The longest side is always known as the hypotenuse, that is your sine theta, correct? The next trigonometric ratio is cos theta. Cos theta means side adjacent to your angle theta. If this is your theta, then BC is the side adjacent to your angle theta. So side adjacent to your angle theta upon hypotenuse. Okay. The next one, tan theta. Tan theta means side opposite to your angle theta. If this is your angle theta, then this is known as your opposite side, right? Side opposite to your angle theta, AB, upon side adjacent to your angle theta, it is BC. Again, we have 3 more. Cot theta. Cot theta will be given by side adjacent to your angle theta, which is BC, upon side opposite to your angle theta, that is AB. We have 2 more. Next, we have cosec theta. Cosec theta means hypotenuse, which is AC, upon side opposite to your angle theta, that is AB. Okay? And the last is sec theta. Sec theta is given by hypotenuse, that is AC, hypotenuse upon side adjacent to your angle theta, that is BC. So we are going to use one of these trigonometric ratios in order to find out the height of the pole. So you need to determine which trigonometric ratio would suit best. Okay? Which trigonometric ratio are you going to choose? It depends on which side is given and which side you want to determine. Here you see, in this right triangle, AC is the hypotenuse, right? Hypotenuse is given. And you want to find out the side opposite to your angle. Okay, here your angle is 30 degree. That means theta is 30 degree. So hypotenuse is given. And we want to find out a side which is opposite to your angle theta, that is 30 degree. So accordingly, you have to choose your trigonometric ratio. That means hypotenuse is given and you want to find out opposite side. So you need to think of a trigonometric ratio which involves the opposite side and the hypotenuse. Correct? All right? Okay. So which trigonometric ratio would you prefer? Okay, in order to determine the height of the pole, means you need to choose a trigonometric ratio which involves the opposite side and the hypotenuse. So which trigonometric ratio? It will be either sine theta or cosec theta, because these are the only 2 trigonometric ratios which involves the opposite side and the hypotenuse. All right, class. Okay. Very good, students. Okay. So I'm going to choose sine theta here. So in right triangle ABC, your sine theta will be given by side opposite to your angle theta, that is AB upon the hypotenuse AC. But see, instead of theta, it is given to be 30 degree, right? So this theta has to be replaced by 30 degree. Okay. Now we know that in exercise 8.2 you have studied the value of sine 30 degree. I need not show you the table now, but all of you have learned, and then you have prepared even exams for that. Okay. So the value of sine 30 degree is 1 upon 2. Okay. The value of sine 30 degree is 1 upon 2. AB is unknown, that is what we need to determine, and AC is given to be 20 meters. Now if you cross multiply, twice of AB will be equal to 20 meter times 1 is 20 meter. In that case, your AB will be given by 20 meter upon 2. That is AB equals to 20 divided by 2, 10 meters. So that we wanted to determine the height of the pole, and the height of the pole is equal to 10 meters. Therefore, the height of the pole is 10 meters. Is it all right? You can just copy it down. Okay. So many students are inviting only at the last moment. Let me check on them. I cannot add now because if I want to add them now, I have to leave the class. That is the problem here. So class, if you are done copying it down, you can please comment on the chat that you are done. Okay? Yes. You can just give a thumbs up or you can say okay. Yeah. If you are done, you can please comment on the chat so that I will proceed with the next question. Okay, so okay, everyone has commenting, thumbs up, and okay. All right, that's enough. Okay, thank you, students. Okay. All right. So this is done, no? The classes that I'm taking now will be even available offline, or will be available offline in this TeachMint app only after 24 hours, okay? So if anyone has missed anything, you can download that video, or you can go through that video through the app. It will be made available after 24 hours because it takes some time to process. Then you can do some revision on that. Okay? Yes. And your attendance and everything is going to be recorded through the app only. I will make you know it later, all right? Yes. So question number 2. You can please refer to the question when I read the question. You can look at the question, okay? Yes. A tree breaks due to storm, and the broken part of the tree bends in such a way that the top of the tree touches the ground, making an angle 30 degrees with it. Very important question, okay? Distance between the foot of the tree to the point where the top touches the ground is 8 meters. We need to find the original height of the tree. Very interesting question. Okay, very interesting question here. That means once upon a time, there was a tree. The tree of mind. Okay, I don't know what kind of tree is it. Okay, once upon a time, there was a tree. I'm going to give the name of this tree as a. So this is a tree. A tree. Okay, T-R-E, tree. When I say tree, then you must be thinking this tree, right? Okay, because they are pronounced the same. So once upon a time, there was a tree. And due to the storm, this tree broke at some point. Okay, so this is the original height of the tree. Okay, this is like before it was hit by a storm. All right. Yes. So due to the storm, what happens? The tree breaks at some point. Let's say that the tree breaks at the point C. Then class, Which one would be the broken part of the tree? The tree breaks at the point C. So which one would be the broken part of the tree? AC will be the broken part of the tree. Is it okay? Now, what happened to the broken part? Did the villagers carry it home to uh, make a fire out of it? What happened to the broken part? Here, if the tree breaks at the point C, then AC is the broken part, okay? AC, this AC is going to be your broken part. Broken part. Now the question says that this broken part, this is your broken part. Just think that this marker is your broken part. The broken part bends in such a way that the top of the tree touches the ground. Alright? Making an angle of 30 degrees with the ground. So if this is the broken part, AC, this marker is your AC. Okay, so the broken part, this broken part, it bends and the top of the tree now touches the ground, making an angle 30 degrees with the ground. Are you clear? Yes. So this broken part of the tree, it bends in such a way that the top of the tree touches the ground. Okay? So this broken part has now become CD. AC has now become CD. Alright? And the broken part makes an angle of 30 degrees with the ground. It makes an angle of 30 degrees with the ground. And then this distance, okay, the point where the top of the tree touches the ground, up to the foot of the tree, it's given to be 8 meters. Okay, itu gasto panigena ben korigena ground. Yeah, the top of the tree touches the ground at some point, right? Making an angle of 30 degrees with the ground. And this point is at a distance of 8 meters from the foot of the tree. B is the foot of the tree. Now we know that tree always stands perpendicular to the ground. So this angle must be 90 degrees. Correct? Correct? Yes. Now we want to find out the height of the tree. We want to determine the original height. Okay, not the broken part or the leftover part. We want to determine the original height of the tree. Here, AB represents the original height of the tree. All right? So let AB be the original height of the tree. Height of the tree. Let AB be the original height of the tree. That is what we need to determine. Now, in the given figure, AB is divided into two parts. One is the broken part AC, and one is the unbroken part BC. So what I'm going to do, I'm going to find out the unbroken part and the broken part. Okay, I'm going to find out the length of the unbroken part and the length of the broken part, and you add them up. That will give you the total height of the tree. So the original height of the tree can be determined by adding up the unbroken part BC and the broken part AC. So let's find out BC and AC, okay, separately, and if we sum up, that will give you the height of the tree AB. Is it okay? So this is a hint. Now let's determine BC first. See, BC is a part of this right triangle, right? BC is a part of this right triangle. Here the angle theta is given to be 30 degrees. This angle theta is given to be 30 degrees. So you want to find out BC. Listen very carefully. For this right triangle, BC, for this right triangle, BC is the opposite side, BD is the adjacent side, CD is the hypotenuse. Now what is given? Adjacent side is given, right? And what do we want? BC. BC means opposite side. So you need to think of a trigonometric ratio which involves the opposite side and the adjacent side. Plus, can you tell me which trigonometric ratio involves the opposite side and the adjacent side only? Tan theta and cot theta. So you can use any one of those in order to determine BC. All right? Okay. So in right triangle, the name of this right triangle is DBC. You can name it anything that you like. BCD or CDB or BCB or BDC, anything that you like. Okay, there are so many permutations. So in right triangle BCD, okay, tan theta. Tan theta means side opposite to your angle theta, that is BC, upon side adjacent to your angle theta, which is your BD. All right, side opposite to your angle theta upon side adjacent to your angle theta. Now theta is given to be 30 degrees, so I'm going to replace theta by 30 degrees. Is it okay? Theta is just a reference. It's given as 30 degrees. Now you know the value of tan 30 degrees is 1 upon square root of 3. BC is what we want to determine. BC is unknown. This is what we want to determine. Upon BD is given to be 8 meters. Is it 8 meters? We have to make sure. Okay. Yes, 8 meters. Now if we cross multiply root 3 times BC, root 3 will get multiplied with BC, right? Is equal to 8 meters into 1, 8 meters. In that case, your BC will be 8 upon square root of 3 meters. This square root of 3 and BC are in product. So if you transpose this term to the other side, it comes as division. So BC we have determined, so done. Now we need AC. But see, class, look at the figure here. AC. Look at AC. AC, this is your AC. AC is not a part of the right triangle, right? No? AC is not a part of any right triangle. So if this is not a part of a right triangle, we cannot determine its length. So what do you need to do? You need to think logically. AC is the broken part. Where did this broken part go? It bends and touches the ground. That means the broken part AC has now become CD. That means the length of AC and CD will be the same because this broken part has bended, touched the ground, and it has been given a new name, CD. That means AC is equal to CD. That means determining CD is same as determining AC. So instead of determining AC, I'm simply going to determine CD. Is it okay? Whatever value of CD you get, that's your AC. Are you clear? Yes, very good. Now, again, in the same right triangle BCD, this time I want to find out CD. This time I want to find out CD. CD is your hypotenuse, right? CD is your hypotenuse. And which side is given? Adjacent side is given. We want to find out hypotenuse and adjacent side is given. So can you guess a trigonometric ratio which involves the hypotenuse and the adjacent side only? We have two of them, cos theta and sec theta. Okay. So you can either use any one of them. I'm going to use cos theta. So cos theta is side adjacent to your angle theta, that is BD, upon hypotenuse CD. But theta has to be replaced by 30 degrees. Okay. Now we know that the value of cos 30 degrees is square root of 3 upon 2. Cos 30 degrees is square root of 3 upon 2. Your BD is 8 meter and your CD is unknown. If we cross multiply, square root of 3 times CD is equal to 16 meters. So your CD will be given by 16 upon square root of 3 meters. Determining CD is determining AC, okay? Therefore, your AC will be same as CD, which is 16 upon square root of 3. Now, our aim is to find out AB. AB means BC plus AC, right? Yes. So now, let's determine AB. Therefore, AB will be given by BC plus CD. Your BC, what is your BC? Your BC is 8 upon square root of 3 meters. Plus your CD is 16 upon square root of 3 meters. Let us take LCM. If the denominators are equal, LCM will be the same, square root of 3, right? There's square root of 3 cancels, so we have 8 meters. Here also they cancel out, so we have 16 meters. 16 plus 8, 24 upon square root of 3 meters. Now we cannot just leave it like this. Okay, denominator, in the denominator, the square root has to be removed. So in class 10, we have studied rationalization, right? So let us rationalize the denominator. Denominator is square root of 3. If you rationalize, I have to multiply both numerator and denominator by another square root of 3. So 24 into square root of 3 meter upon square root of 3 into square root of 3 is 3. XC. X into x is x squared. That means square root of 3 into square root of 3 will be also square root of 3 square, right? But square root cancels out, so we have 3. Alright? So here 3 8 times is 24. So the original height of the tree is 8 square root of 3 meter, which gives you the complete answer. The original height of the tree before it was hit by the storm is 8 square root of 3 meters. You can just copy it down, okay? Yes, and if you're done, you please comment on the chat so that we can proceed with the next question. Very fast in commenting. Okay. Okay, everyone is saying okay. Okay, thank you. That's enough. Okay, only 3-4 chats are required. 3-4 comments are required. All of you need not comment. Okay, then, say our class timing will be only 1 hour. If it is already 1 hour, then you please comment, okay? Because I don't have a clock in this room. So once our required time, our time is only 1 hour. So if 1 hour is completed, then you can comment, okay? Yes. So Thursday, Friday, tomorrow and day after tomorrow, so we are going to have a class on the same time. Okay, from 9 to 10. So you please be ready for the classes, okay? Tomorrow and day after tomorrow as well. So now let's roll on with question number 3. Okay. Let me read the question. When I read the question, you can also refer it to your text from your textbook, okay? Yes. A contractor plans to install 2 slides for the children to play in a park. There are 2 kinds of slides, okay, for the children to play in the park. For the children below the age of 5 years, she prefers to have a slide whose stop is at a height of 1.5 meter and is inclined at an angle of 30 degrees. Whereas for older children, she wants to have a steep slide at the height of 3 meters above the ground, alright, and inclined at an angle of 60 degrees to the ground. What should be the length of the slide in each case? Oh, you want to find out the length of the slide in each case. So there are two types of slides here. One is for the children below the age of 5 years. And another one is for the children, for the older children, that means who are 5 years and above. Okay. One is for below 5 years, and one is for the children who are above 5 years. maybe up to your age, 16 years also. Okay. All right. For the children below 5 years, the top of the slide should be at a height of 1.5 meter from the ground. And for the older children, the top of the slide should be at a height of 3 meters above the ground. Okay. So what should be the length of the slide in each case? And the angles are also given. For the smaller slide, the angle should be 30 degrees with the ground. And for the older children, like you, the slide should be at a height of, okay, the slide should be at an angle of 60 degrees to the ground. Heights already we have mentioned. So let me first draw for the children below 5 years. For the children below 5 years, this is your slide. This is the slide. Okay, this is the slide. Let's say that AB is the slide. AB is the slide. Okay, and the slide makes an angle of only 30 degrees with the ground. Okay, so BC is the ground. This is the ground. Also, the question says that the top of the slide is at a height of only 1.5 meter from the ground. 1.5 meter from the ground. Very short. Okay, the top of the slide is at a height of 1.5 meter from the ground. Are you clear? So this is going to be your first slide for the children below 5 years. Now for the children above 5 years, the slide is going to be very steep. This is your slide. This is your slide. How dangerous it is, no? Let me give this by PQ. PQ is the slide. The slide makes an angle of 60 degrees with the ground. Okay? And the top of the slide is at a height of 3 meters above the ground. Okay, 3 meters above the ground. Oh, that means this slide is double the height of this slide. All right? So in each case, we want to determine the length of the slide. For this slide, AB is the length. For the other one, PQ is the length. Very simple. Okay. So let AB be the slide for children below 5 years. And PQ be the slide for children above 5 years. Okay? We cannot solve them simultaneously, so we are going to solve them one after the other. First for this one. For this right triangle, this is your theta set. Theta is 30 degrees. The opposite side is given, and I want to find out hypotenuse. Opposite side is given, and we want to find out hypotenuse. So you need to think of a trigonometric ratio which involves the opposite side and the hypotenuse, right? Which trigonometric ratio? Sine theta. Sine theta. So in right triangle ABC, sine theta will be given by side opposite to angle theta, AC, upon hypotenuse, AB. Theta is 30 degrees, so I'm going to replace theta by 30 degrees. Sine 30 degrees is 1 by 2. AC is 1.5 meters. AB is unknown. This is what we want to determine. If you cross multiply, AB times 1 is AB is equal to 1.5 times 2. 1.5 multiplied by 2, 3.0. 3.0 meters are only 3 meters. You can multiply in 3, okay? Whereas in the bigger right triangle, PQR, the same thing, opposite side is given, and we want to determine the hypotenuse. So sine theta, so sine theta 60, sine theta is equal to side opposite to angle theta upon the hypotenuse. All right. Sine 60 degree is square root of 3 upon 2. PR is 3 meters, PQ is unknown. PQ is unknown. So if you cross multiply, square root of 3 times PQ is 6 meters. So your PQ will be 6 upon square root of 3. This is very complicated. Sine 60 is square root of 3 by 2. PR is 3 meter, PQ is unknown. Okay. So the same way we can rationalize. Your PQ will be equal to 6 upon square root of 3. Let us rationalize the denominator. Square root of 3 upon square root of 3 meter. 6 times square root of 3 meter upon square root of 3 times square root of 3 is 3. 3 2 times is 6, so it's twice of square root of 3 meter. So these are the length of the two slides, alright? Yes, which is our desired result. Length of the slide for the children below 5 years is 3 meters, and for the children above 5 years is 2 square root of 3 meters. If you are done copying it down, then you can please comment on the chat, okay? 2-3 chats would be enough, 2-3 comments would be enough. Okay, all right. So we'll go for the next question. We still have, I think, around 15 minutes, 15 or 20 minutes. So we can go for at least 2 more questions, all right? Every class, if we can work out with 5 questions, then we can finish the chapter in 3 days, okay? 3 classes we can finish up the chapter. So as I wrap this out, you can please get yourself ready with the next question. You can at least read the question, write some given informations, and wait, okay? Yes. So we have 53 students altogether, 62 enrollment out of 250 something, only 53, 54 is live. One is going away and coming back again. 53, 54, okay, it's changing every second. Maybe network issues. So question number 4, let's go with question number 4. Okay. Plus, there is a request. I want you to use your full name because even your attendance are being recorded, okay? So even though you do not know your class roll number, you please, when you log in, you have to log in with your full name because your attendance will be recorded from the app itself according to your name, okay? In order to avoid any confusions, I want you to just write your full names. There are some students with a half name. I saw one student name with 32B. I don't know who is 32B. Don't write that kind of names. Okay. All right then. Question number 4. From question number 4, the question talks about elevation and depression. Okay. So please do not forget, before we started solving the exercises, we first discuss what is elevation and depression. That is what we discussed. So let's see. The angle of elevation. Elevation means you are looking up. All right. Elevation of top of a tower. That means you are looking up at the top of the tower. Elevation means looking up. Elevation of what? Top of the tower. So you are looking up at the top of the tower. From where? From a point on the ground. So you are looking up at the top of the tower from the ground, which is 30 meters away from the foot of the tower. That means the observer is standing on the ground. The observer is on the ground and he is at a distance of 30 meters from the foot of the tower. All right? Yes. Our aim, our objective, our mission is to find out the height of the tower. So there is a tower. There is a tower. A, B is your tower. A is the top, B is the foot. Right? A, B is your tower. A is the top, B is the foot. We know that tower always stands perpendicular to the ground. Okay. Where is the observer? On the ground. On the ground. Observer is on the ground. So from the observer, okay, let me explain it to you again. AB is your tower. A is the top. B is the foot. Okay. Where is the observer? On the ground. What is he doing? Looking up at the top of the tower. So an observer is on the ground. C is the observer. Then I told you, from the eye of the observer, you always draw a straight line. Is it okay? Yes. A straight line parallel to the ground. Then that line will be known as your horizontal line. This is your horizontal line. You draw another line, an imaginary line, connecting the eye of the observer and to the point where he is looking. He is looking at the top of the tower. So you draw another line connecting his eyes and the object, top of the tower. This line will be the line of sight. This is the line of sight. This is the horizontal line. So this is the horizontal line. This is the line of sight. Angle between them is the angle of elevation. So angle of elevation is given exactly to be 30 degrees. Okay. Observer is here at C. How far is he from the foot of the tower? He's 30 meters away from the foot of the tower. The tower always stands perpendicular to the ground. Right, this seen any tower standing like this. No, right? Tower always stands perpendicular to the ground. So our objective is to find the height of the tower. Okay, height of the tower. Now in this right triangle, this is a right triangle. Here AB is the side which is opposite to your angle. So this is your opposite side. This is the adjacent side. This is the hypotenuse. Hypotenuse has no role to play here, because adjacent side is given and we want to determine the opposite side. So tan theta or cos theta. Alright. So our objective is to find the height of the tower. So let AB be the height of the tower. Okay. Now in right triangle ABC, angle is given to be 30 degrees. So tan theta. Tan theta means side opposite to angle theta upon side adjacent to angle theta, but theta is given to be 30 degrees. Then 30 means 1 upon square root of 3. AB is unknown. BC is 30 meter. If you cross multiply, square root of 3 times AB is equal to 30 meter times 1 is 30 meter. In that case, your AB would be equal to 30 upon square root of 3. This is not the complete solution. We need to rationalize. Denominator should not be in square root form. Okay, we have to remove this square root from the denominator. So in order to do that, we have to rationalize the denominator. That means I'm going to multiply by square root of 3 in both numerator and denominator. So 30 into square root of 3, 30 square root of 3 upon square root of 3, square root of 3, 3. 3 10 times is 30. So the height of the tower is 10 square root of 3. This is how the answer might be given. But see, if you want to find out the exact height of the tower, then in that case you need to know what is the value of square root of 3. And the value of square root of 3 is determined to be 1.732 approximately. Square root of 3 is irrational number, so its expansion is non-terminating, non-recurrent. Okay, but you can use only up to 3 digits after the decimal. Okay, so knowing the value of square root of 3, which is 1.732, you can multiply it with 10. That will give you the exact height of the tower. But if you don't want to do that, if you leave up to this 10 square root of 3 meter, also you're going to get full marks. There's no problem regarding that. Okay. So you can copy it down. If you are done, you can comment on the chat. I think there is some issue here. Oh, this is me. So, okay. So it's about time. I think it's already time. Okay, class, I think if it is all, if the time was already up, then we will wind up here. And tomorrow we are going to continue with the same exercise at the same time with the same teacher. So thank you so much for attending the class. I hope you have learned something from today's class. Recordings will be available after 24 hours. So if any one of your friends have missed the class, okay, or due to some network issues, you can just help them with the recording videos that we have taken today. Okay. Thank you so much, class. We'll wind up the class today. So you can now log out from the app